think what we could do, we can wait for 1 or 2 more minutes now to see if somebody else is dropping in.
I have some funny sound in my computer. I don't know where it's coming from. Let me mute myself. I'm still there.
No, it's not. Can you mute yourself again?
Yep. And if I unmute myself, can you hear anything?
So when you mute yourself, I don't hear anything, but this can be problematic if you want to give a talk.
I think this might be on your end, Tim, actually.
On my end?
Yep.
Oh, that's interesting. I mute myself now?
Yeah, that was it.
Yeah. Oh, someone is asking for the demo. Okay. I can try that. That's all right. Yeah, I want to try one last thing in case this could work. Okay. What if I do? All right, I'm gonna start OBS camera. Can you see anything? No, you can't. What if I remove the virtual background? There you go. Can you see anything now? Yes, you can see yourselves. And can you see this video? You can, right? Good, but there is no sound coming from my end, right? No, I don't think there's any sound coming. Okay, then I will need to just share the screen and hope for the best. Okay. There we go. And I'm gonna stop this. Yeah.
Carlos, you tell us when you're ready.
Yeah, let me just place the virtual background. That's okay. And can you see the Games Week Berlin? Is it mirrored or is it okay?
It's okay.
It's okay? All right. So then I think we can start.
Okay, wonderful. So welcome everybody to this early afternoon session of the Games Week Berlin, and welcome Carlos Gonzalez Diaz. Carlos is a PhD researcher in intelligent games and games intelligence, IGGI, Center for Doctoral Training at the University of York, Goldsmiths, and Queen Mary Universities. So that's a lot. Can you just maybe quickly explain what that means before you start with your talk? Or is it integrated in your talk?
It is integrated, but I'm happy just to explain it. It's I mean, if anyone here is thinking of pursuing a career in research in games, it's an incredible opportunity. You basically get paid for 4 years of your life to research on a topic of your choosing among, leading experts in artificial intelligence, and games design and the intersection between artificial intelligence and game design. So that's basically where I am, and that's basically what I'm going to talk about today. A very specific point of research in the intersection between machine learning and games development.
Okay. So I would say Carlos and his talk, Enhancing Movement Interaction Design for VR Games Through Machine Learning, is definitely ready to go. everybody enjoy. Carlos, here we go.
Perfect. Thank you. Okay, so let me share my screen. All right. So, guys, can you see this? I hope so. Actually, now I think about it, I don't have access to the chat. But Tim, is it okay? Can you see my slides? Wait a second. Okay. All right, now it should be fine. Right, let me know if not. Just unmute yourself if it's not okay. Okay, so let me talk to you about my talk, Enhancing Movement Interaction Design for Virtual Reality Games Through Machine Learning. This is me. If this works, there you go. This is me. I'm Carlos. I'm a massive nerd about games, technology, and science. And I'm doing this really cool PhD in artificial intelligence for virtual reality games between 3 leading UK universities. And hopefully I will get you very excited about this topic the same way that I am. This is the team that I'm working with. My supervisor, Dr. Sebastian de Terding. He's actually a professor recently at the University of York. He's a philosopher of playful interaction, a very smart person, lots of really good publications. You should check him out. He has really interesting books published. And Dr. Marco Gillis, which is my supervisor at Goldsmiths, who has more than 15 years of research into virtual reality. And in a way, he actually started this idea of, can we use machine learning, to in a creative setting to make more interesting and nuanced movement interactions in virtual reality, right? So you can imagine that this idea it's quite an interesting one. So what is this thing about movement interaction design, right? Like in this talk, I'm gonna talk specifically about this concept, right? Which refers to the way we interact with different situations, events, actions in virtual reality through movement, right? Compared to how you traditionally do in a keyboard or laptop, just by pressing a button, by moving your mouse, clicking on something. The idea here is to make the most of your physical body movement, right? And of course, how to enhance this movement with machine learning, right? Because we have this big limitation in terms of sensors, hardware, and even sometimes with physical abilities, right? But let's go there slowly. Of course, like machine learning is a big buzzword, so I got into this because of the buzzword, but I hope you will find it fascinating because of the overall concept. So in video games, right, we have the idea of game controls, right, and there is plenty of research around game controls. Paul Kearns, who's a very well-known researcher as well in the area of games research, he has a very interesting paper from 2014, where he actually finds out that game controls are the first thing that players encounter in the interaction with the video game, right? When you play video game, automatically you are interfacing with the game through controls. And this is a concept that people many times don't think about it, but when asked and when playing with the game, really surfaces, right? There's lots of different research for decades around how game controls can affect the player experience, right? The perceived feeling of playing a game. There are different dimensions of this player experience term. You have immersion, you have engagement, you have enjoyment, you have different granularities around these different definitions. But what is clear, there is plenty of evidence that the game controls affect player experience in a different manner, either positively or negatively. And in terms of game controls for movement interaction, motion controllers, there's actually a lot of different motion controllers and very little established practice around what is a standard way of interfacing with a movement-based game. In comparison with a gamepad game, a shooter game that you expect how to play Call of Duty, you expect how to play Halo, but do you really expect how to play a motion control game? Well, it doesn't seem to be the case. So in this talk and in my research, I focus specifically on virtual reality, right? So how are game controls in virtual reality? Well, this slide, I'm just basically placing what is like, the current state. And you can see from this quick look that controllers can greatly differ between platforms. So on one part of this image, you have what is known as the wand controllers, right? This is the traditional way of making motion controllers. Basically, they have a known ergonomic shape, which is a wand, very similar to the remote of your TV, but you enhance them with motion tracking technologies, right? On one end, you have the PlayStation Move controllers, touch controllers that incorporate the joysticks and buttons in a more ergonomic way, and the shape of the wand is slightly different, but still it is a wand, and the Vive controllers, right? And there is, like Windows Mixed Reality headsets and many other platforms, they still use this paradigm. But of course, we also have the emerging paradigm of hand interaction, which is a super exciting field. With the Oculus Quest right now, they're having this experimental hand tracking technology, and it seems that it's going to be one of the options available to interface through virtual reality. And this poses lots of different challenges in interaction design, right? And of course, the affordances of your hands are very different to the affordances that you have when you're holding a one-based controller. But we have also controllers that are kind of in between. Like the idea of, well, I still want some haptic feedback, I still want some physical feeling to the controller. How can I go about it without making a wand that you just hold as a TV remote? Well, the Valve Index controllers, previously known as Knuckles when they were in development, they're a really good example. You can have your hand fully open. You don't need to hold the controller itself because the controller is attached to your hand. And there's some very interesting affordances that are yet to be explored by developers there. And we have other solutions, such as, well, we know that I'm going to make a controller specifically for shooting games, such as Sony did with their PlayStation aim controller. And there, there's a lot of interesting questions about, where you place the buttons, the joysticks. The Nintendo Wii, the Nintendo Wii, the Switch, they had this really smart idea about having the motion controllers to be able to morph into something else, right? You can just stick them into a case and make a regular controller. And you can separate them, and you can give each controller to a player, and then you have like little controllers that are still motion controllers. And the affordances here are also very different. So the conclusion I want to reach in this slide is that basically motion controllers greatly differ, and the technology inside them also greatly differs, as well as the affordances they provide when interacting. So, developers have a hard time implementing this. So what can be a solution here? Well, when you are creating game control schemes for your VR games, developers find out that, again, this is not an easy solution. It's a very novel field. The first game came in 2016. You remember when the Vive came out, all of these lab experiment games. It was super interesting. But as I stated before, virtual reality presents a lot of challenges in terms of interaction design. And there are different solutions right now that we can quickly go through. For instance, we have one of the most well-known VR games to date, which is Job Simulator, one of the launch titles of the first generation of VR in 2016. And here, the way I've called this control scheme is direct input mapping. Why is it direct? Well, basically, here you are just mapping your exact body movements to an action. In this game is completely overusing, in a very smart way, direct hand interactions, as in like, I am grabbing something and I'm throwing it away. It's a very simple interaction. There is not nuance in the way you grab something. There is not nuance in the way, you need to throw something because you need to do accelerated movements. And it's very repetitive, but it works really well. That's a good solution. And of course, you just like press the trigger and just grab something, which is works well for this game and many others, of course. Then, we have a bit of, let's think of a specific nuanced movement I want to do. And one of the solutions that has been explored really successfully, for instance, in Beat Saber, is simple directional movements, right? Here, the game, again, like you don't need to grab anything. You actually are just standing, but you will have a bit more nuance in what you are required to do. Here, you need to slice with your lightsaber to the rhythm a series of cubes. And it's super fun, and the music is fantastic, the graphics are incredible, and it works really well. But in the end, you are just required to do slashes in one direction. There is not much more granularity to the way you interface and interact with this game, right? Because it's complicated, but still works well. But it limits what developers can do, and it limits the player experience that the players all over the world are having. So we can have other solutions, which is, for instance, complex gestures. But the problem with these complicated gestures and interactions that you're having, such as the archery in the lab, one of the first games in 2016, is that, well, this is hard coded. Developers, traditionally in game development, there hasn't been a long history of feature extraction, movement analysis, signal processing. So here, developers very smartly and really well polished, they have found out through a series of scripts a way of recreating this feeling of I get my bow, I get my arrow, and I do archery, right? And it feels really good. But there is a lot of work here and requires a lot of iteration, and it's not easy to maintain and not easy to extend if you want to do different things, not only just shooting arrows, right? So this is a good solution, but again, it's very complicated, very costly, poses several challenges. So here, because of all these challenges that we are facing and the potential opportunity to create simpler and quicker movement interactions, we have interactive machine learning as a potential solution. So where is this idea of interactive machine learning coming from? Well, actually, this idea was used successfully in music motion research. This researcher here, who is an amazing person, Dr. Rebecca Fibring from Goldsmiths University, who now moved to University of the Arts London, but is still working with both institutions. She's highly demanded. She actually, she's a musician, and she was also a computer scientist, so she could program and she could make music. And she found out herself when doing virtual instruments that it was really hard to translate the nuance of your movements when playing a violin or when directing an orchestra or even, just doing anything that requires a bit of skill and movement in playing music to how you can interact with a computer. And, she was also finding that she was not the only one getting this problem. So what if we allow musicians out there to train the system to understand how they move, to teach the computer into the very specific nuanced way of playing an instrument? Can they translate these skills into a computer? Well, she did it, and it was very successful. The way she went about it is that the user can program, quoting unquote, in the system the way they want, using their movement as the example training. If I want to play a very high pitch note, I will move my hand here with a specific motion. If I want to play a very low pitch note, I can place my hand at the bottom of the screen and just do a very specific movement. And by using machine learning algorithms, the system can train, which in the end is not a completely unknown concept for us gamers and game developers, because it's actually how keyboard games offer the option to remap keys. If you think about it, well, I know that they can jump. Jump is an action. I can then jump with space, or I can completely change that to jump with the left mouse click, right? And many players are happy with this customization, right? So it's not completely unknown to us. Anyway, going into more depth into interactive machine learning, I borrowed this diagram from one of my favorite papers, and I'm leaving the reference then, from 2018. And basically the idea around interactive machine learning is that the user, the human, is in the loop of the training and the learning. So here you have the user that is interacting both with the data and the model constantly, iteratively, right? So the word that I ever heard for a model is usually an algorithm. There are different algorithms, every algorithm has its cons and its pros. But there is this very interesting idea of, depending on what data you input to the algorithm, to the model will learn in a different way. And here, since we are concerned about movement and nuanced movement interactions, This is very interesting because every user can tailor how the algorithm learns. Well, this is complicated, but don't worry. Thanks to our funding from Google, Epic, one of the Epic mega grants, and the EPSRC in the UK, we've managed to build this really powerful tool called InteractML, which allows you to do visual machine learning scripting directly in Unity. Right, so the idea behind InteractML is to make interactive machine learning easy. Right, it's fully open source for Unity 3D. We have a working plugin for Unreal, but that's still very early stages. InteractML for Unity is still in very early stages. But the Unreal one is like even more primitive. But in both, the idea behind InteractML is to use visual node programming, very similar to how would you interface with your gaming blueprints, right? And well, this requires minimal coding experience, right? So you can program your machine learning model directly in the graph. If you want to do anything very complicated because you're a developer, you can still do that. But if not, that's perfectly fine because you can interface with the existing Unity scripts, the standard assets, without looking at the code, which is quite nice actually. You can just go to the website interactml.com. It's fully free, open source, under an MIT license. This is a public research project. There is no profit behind this, so you're very welcome to experiment, and to just play with it. And as well, if this looks interesting to you and you like playing with this, you can join us in our Discord. So in our Discord, we have a little community where we organize workshops, game jams, and we as developers and researchers of InteractML and this field of using machine learning for movement interactions in games, we are actively researching with the people in this Discord, understanding what you as developer you can do, what you feel InteractML needs to have or don't have, and everything that can help research move forward in this field. So if you're interested, please go to bit.ly/VR interactions and just join the Discord. Don't worry, these links will be shown again throughout the presentations, and you can get my contact details in every slide and just send me an email and ask about it. But again, this talk, I guess, you all want to learn a bit more about machine learning, right? This very, very exciting concept. Well, don't worry, because machine learning in the end comes down to a few simple concepts. Every algorithm in the end do a few of these simple concepts. And here in InteractML, we have two of them, which is classification and regression, which is the first two models that we provide. And the third one is classification, but over time, right? I will explain a bit further and more in detail now throughout the slides. So here we have three potential scenarios where we're using interactive machine learning. In the first one, with the audio, the input for our machine learning model is our voice, right? We are just inputting to our voice to InteractML, and we are training a classification algorithm to detect whether what we are saying corresponds to a specific category in an application. For instance, we can say to our fake Alexa that we are developing in Unity, we can say, hey, fake Alexa, can you change to level 3? And then, the fake Alexa will change to level 3, or in this diagram, just produce a sound, right? Another potential input we can have is video. I can input the video feed of my camera to my model, and I can say, I want to detect and classify what's going on in the screen. So when I show you the image of a horse, I want you to tell me, well, this is a horse. And when I tell you an image of a cat, I want to tell me this is a cat, right? This is another classification example. And another really interesting case, again, this correlates more with what we're doing, is hand pose, right? I show to my camera or through my leap motion tracker or through my Oculus Quest hand tracking, this is one pose, this is pose A, this is pose B, this is pose C, and so on, right? So classification basically refers to the task of assigning a category or label, that's the word we use in machine learning development, to an incoming input, right? So categories or labels, they are mutually exclusive. This is not the same as this, right? And they will never be the same. And the classifier always knows one of the known categories, right? So it will never output something else. So if I give it, because I'm training this iteratively and I have the power to train it live, I'm training my computer through InteractML to say, well, this is fireball, this is shield. If I now do this movement in front of the camera and I haven't trained my algorithm in this new movement, my algorithm will not say unknown. Instead, it will try to say, well, this is probably closer to this than to this. So it will say fireball, right? Which is a problem. And also is an opportunity because the classifier will constantly do something that might be potentially useful. So you need to be very careful how you train your classifier, and you need to be very smart about which data you train your classifier on. Then, we have another concept, which is the concept of regression, right? Here, regression works a bit differently to classification, and it's useful to tackle different problems. In regression, the algorithm, our model, is computing a numerical value from the inputs, right? So the idea is that your output, the output that you get from the algorithm, from the model, changes smoothly as the inputs are changing, right? So in this example, in this diagram I have here, I can say, I'm training with this hand pose. This is a triangle, maybe it's a shape of an object in the game. This other one is a circle, right? This is the shape of my game object. All right, with regression, as I am moving my hand from open to close, the output changes smoothly, and the algorithm is constantly, every frame, trying to make a prediction with what would be the in-between value that corresponds to your movement. So for instance, we can control continuous parameters such as volume or position. We can say, right, I want here, I'm training my algorithm, here is zero volume, no volume. But when I move my hand to this part of the screen, it's gonna be maximum volume. And I train, just with these two inputs. This is a 0 to the left, 1 to the right. And as I move my hand after the training, the algorithm will try to predict and infer what is the right value for in-between positions, right? So if here is 0 and here is 1, probably somewhere here is 0.3, and here is 0.5, and here is 0.7, and here is 1, right? So, you can use it for different creative purposes. And then the last model that we are providing in InteractML is dynamic time warping, or DTW, which is a very, very fancy name, but don't worry, because in the end, this is just a classification over time, right? This is a specific name for the algorithm, dynamic time warping, or DTW, and it just measures the similarity between temporal sequences that might vary in speed. Just imagine of gestures, right? Gestures you do in front of the camera, gestures you do with your VR controller, because these kind of algorithms, actually this specific algorithm is used to recognize patterns or gestures over time, right? So you can have a spellcasting game, and you can be like, right, so when I do this movement, it's gonna be launching a fireball, right? I'm classifying my movement over a specific period of time into an action. Or I could say, well, the opposite, just moving my hand from right to left, is going to be, I don't know, blocking the attack of the enemy, right? So it's the same concept of classification, but it refers to specific time-based movements. But you can also think of movement as, not only necessarily your body, but maybe music, how the music moves or changes in a specific period of time. Or, even the position of something in the game, not only yourself. You can say, well, whenever I have a bird in the game that moves in a specific way at a specific moment, in a specific period of time, I can classify that with more nuance. So you see, not very complicated when you understand what's going on. But apart from this, as part of the InteractML project, we are also organizing workshops to teach people how to make the most use of their creativity with InteractML. So we are basically organizing both video call workshops and Rec Room workshops. If you haven't tried Rec Room, you should try Rec Room. It's a fantastic virtual reality platform. We're here. The idea is that we are helping you understand what can you do with your movement, and what kind of design methodology you can follow to make the most out of your embodied thinking, right? This idea of thinking with the body, not only as the final interface you're going to use, but also as the design interface you're working with, right? So again, if you join our Discord, if you're interested, you can just join. We can let you know when it's going to be the next one. And also in the InteractML website, you can download InteractML. Of course, please play with it. Please find every bug we have and let us know. But also in the InteractML website, you have a mailing list that you can join. So this will be the end of my talk, enhancing movement interaction for VR games through machine learning. I'm gonna remind you to join us in our Discord. You are not gonna regret this. And before I leave, I'm gonna share with you a little teaser about machine learning. So just let me, about InteractML, sorry. Just let me play this full screen. Actually, I'm not sure if I am sharing with audio. Let me know if you can hear this, okay? Can you hear this? Right, I really hope you could hear that. If not, please go to our InteractML YouTube channel, and you can find there a few videos about the teaser. You can also find a regression and a classification example in VR. And yeah, I think that would be all for the talk. So let's go and have any questions you may have.
So thank you. Can you hear me?
Yes, I can.
Wonderful. So thank you very much, Carlos, for the talk. Right now it's the best time to ask all of your questions. We had some, not really audio problems, but we realized that somebody was clicking and breathing in the background, but we don't know where it's coming from. So apologies for those very, very human, quite silently disturbances. I hope that it was not really loud, so it was all fine, and all the content you wanted to bring through was I think was received.
Okay, perfect.
So maybe I have a question in the beginning. Do you know, like, how easy is it to combine your plugin with like hand tracking software that's on the market, something like Manus, for example? Have you worked with that?
Yeah, indeed. Actually, we were part of a virtual reality hackathon that was organized by the Digital Catapult in the UK, which is a It's basically a company that makes, connections between other companies in the sector. And we helped them, and we prepared a project with InteractML for hand tracking with the Quest. But we had hand tracking already incorporated with the BitMotion, and I mean, you can, with InteractML, we are giving you a node interface and algorithms that, it's very easy to plug things in. So you can really use anything you want. You can use your microphone. You can use, if you have access to mouth or eye trackers, it will work, without any problems. We did a project as well and at the Vive developer game jam in January, before everything started and all the COVID situation happened. And actually, we were working there in a very small 2-day project where we were combining, all your movements together with information from your eye trackers and your mouth trackers, and it was very easy to do. You just send that array to the algorithm through the interface, and you will be able to train it.
So there's a one question from the audience, from Jochen Schmidt. Great talk, thank you. InteractML addresses developers only, or can this be applicable for users as well? If yes, how much must the user learn or know about the system before get used to it?
That's a really good question. So if you are referring to users as players, you can use, this is in the end meant for players to interact with, but InteractML as an interface is meant to be used by developers to allow players to use machine learning, right? So that's in the end a design decision that you have, right? It's still an open research problem, right? Like how is a very novel thing, right? So how much players should know about machine learning before playing with your game? Because, lots of researchers and lots of designers, they believe that that should be invisible to them, right? You shouldn't be aware that while you are playing your game and, you are using your movements, with your sword and so on, you should maybe not know that there is a machine learning model in the background analyzing all your movements and, classifying them into the right action in game. Or maybe, you want to allow that knowledge to your users, and you say like, well, in my game, actually, I want to make this more explicit, and I want to state that actually you can train this system. You're the player, and you can train the model behind. So you can teach the game new things. You can teach the computer, I don't know if it's a game about pets. You can teach the computer new tricks for the pet, and classify or make a regression with, when I move my VR controller in this way, I want the dog to bring me something. It's in the end a design choice, but as an interface, InteractML is meant for developers in Unity to create these experiences.
Jochen, was this the answer you were looking for? We just continue then with this conversation. So this speeds up AI design, or do you expect new genres based on IML?
That's a really interesting question, actually. Right, exactly, artificial intelligence. Artificial intelligence is a big word, right? So what do we mean with artificial intelligence, right? So in my opinion, machine learning can be used for artificial intelligence purposes, but it's not necessarily part of artificial intelligence research. I mean, it is in the umbrella term because it's much easier and so on. But when you look down at the specifics of the systems, actually one thing is making intelligent agents that can take decisions by themselves. There are different approaches to make them intelligent. One way might be using machine learning, but maybe you don't need machine learning. Maybe you can use, other technologies to make your agent intelligent, such as decision trees, behavior trees, state machines, procedural decision algorithms that are not statistically based, because in the end, machine learning is a field of statistics, right? You're using mathematical functions, statistical mathematical functions to infer decisions, right? So your question is very interesting, and we could speak about the philosophy of artificial intelligence research and machine learning research and mathematical research, right, for hours. But basically, I believe that there is a very different field of interactions and game experiences not yet explored that rely on machine learning algorithms learning from either developers or players or both, and not necessarily tied to intelligent agents, but rather creating new unknown experiences that we can't think of right now.
What about gestures that are probably a little bit harder to recognize? I mean, if you say something like this, or maybe like this or this is kind of easy because probably it's just like one hand and probably depending on the tracking, easy to recognize. But what about if you want to imitate the playing of instruments with, like, you began with it, and having something like a drum roll, for example, which is rapid movement? Is it harder to do to recognize rapid movement, that the machine learning can then have the right interpretation of what two hands are doing, or maybe if two hands are not like this, so like 10 centimeters away from each other, but doing these kind of movements? Are there difficulties?
Yes, there are no difficulties in terms of recognizing or processing data. That's very easy, right? The difficulty here is how we train the machine, right? How we train the model. Because these are just models that learn from you. And in order to learn, they need training data. If you give them very dumb training data, they're going to be very dumb algorithms. But if you give them very smart, well curated data, your algorithms are going to be much smarter, right? And of course, it only gets more powerful as the more smart data you give them, right? So in supervised learning, which is this approach followed by InteractML, it's called supervised learning because you have someone that knows a little bit what the algorithm should look at, right? So for instance, as you explained, you get really good examples. You said quick drum movement versus having your hand separated by some distance, right? Here we are already talking about interesting things to look at in your movement. One is the speed of your movement, and the other one is the distance between the objects you want to analyze, in this case in the hands. So maybe here what you can do very smartly is, instead of just giving the raw information, I just give all the positions of my hands while I'm doing the drums, everything, then maybe that's not very smart data. It's too big, and your algorithm is not going to learn much. But instead, you just give the speed, only the speed. Then your algorithm can, make better decisions. And for the hands, instead of just giving everything, every position, your entire body, just give them the distance between the hands, right? Then your algorithm, just with these smart choices, can be very, 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 very smart as well. But of course, this is very dependent on what you're trying to do, right? If you're going to do a drum game, then you probably want to do speeds. If you're making a game where you are controlling something, and you have a bit more granularity in terms of controlling a drone, you're controlling something with your hands, as you're a Jedi. Maybe here you want to mix features, we call them, right? You might want to mix your speed, how quick you're moving your hands, with how far away are the hands from each other, with maybe even what is the position in the Z value of space. Maybe just this position will give you smarter information for your models.
We've got a question from our volunteer who's not able to ask in the Q&A because this is only available for the audience. So how easy would it be to integrate accessibility options into this? Players with probably one hand, etc.
That is a wonderful question. Again, really, really good questions from the audience and from the volunteer. So here, actually, this is a very exciting potential field of research, and of course, of products as well, because machine learning is not really used in industry right now, right? There's this connection between machine learning, expertise, and machine learning has been used for decades in many other fields in software development, but for some reason not much in games. So actually, there is a very clear opportunity for accessibility. So as I was saying, you can use any input you want, right? And you can train the model the way you want. So actually, this really opens up the door for saying, well, I don't have a traditional controller, or I have very limited set of inputs I can teach to my machine. But as I was explaining before, I could really just choose very smartly what I'm teaching so that the machine can make very smart decisions. So let's say that you have some physical disability and you have very, very, very subtle neck movements. That's okay, because if all your data that you are training to your machine, and this is a process that is very quick, it maybe takes like a few minutes for you to teach the machine can learn really fast, is subtle movements, and you have all subtle movements, then your algorithm is going to learn very well the nuance in your subtlety of your movements. And you can very, very easily probably use a regression, for instance, to use your subtle neck movements as the joystick. And the algorithm is do all those time-consuming mappings that traditionally we do as game developers. So indeed, it can be used. And we have already a PhD student that started this September, where her research is on diversity of bodies and diversity of body ability, and how can we use InteractML with this diversity of body ability.
Okay, there's another one coming from the audience. Jochen is interested in how InteractML is organized on Unity platform. Is it all coming with your plugin and done locally, or is it connected to cloud rendering?
That's a very good question as well. So it's all local, it's all offline. InteractML, it's an open source public research project. It has an MIT license. So, there is always this question of, but, machine learning research, AI research, this can be a bit dodgy. Where are you sending the data? What are you doing with it? Well, this is very straightforward with InteractML because everything is local. The algorithms and the models and everything, it's natively written in C++. Actually, these algorithms are very lightweight. They're very, 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 lightweight. I think that's the right word. So it takes a few seconds to train. And these algorithms are not meant to, you could use them if you have the patience and you want to do big machine learning project, but that's not the idea, right? The idea here is that they will work with smart, small data. Instead of big data, here the idea is small data, smart, small data. So since it's all trained locally, right, and the models are lightweight, it takes a few seconds, maybe some minutes if you have a big data set, like up to, I don't know, like 5 minutes, maybe a big data set, right? And you don't need to worry about privacy. You need to worry about where is the data being sent because it's all done locally in your computer. If you deploy your game into someone else's, like, you ship your PlayStation game or you ship your VR game through Steam or through Oculus Quest, all the processing is done in the device. But again, these models are very lightweight, so you shouldn't worry about performance. This said, though, there might be some situations if you are not using smart data and smart features where you are just giving too much to the model. And maybe the model is taking good decisions, but since you're inputting so much information to the model, it's a bit slow. But that's why we have the Discord, and that's why you can join the Discord, and we can discuss about this, when you have a specific project, and we can help you also understand well what kind of smart data you can train your model on.
All right. Is there another question from the audience or from the volunteer? If not, I would say I would thank you very much, Carlos, for this extremely interesting talk. It was very insightful. And yeah, so you keep in touch on Discord. And thank you all for joining. I hope to see you in one of the next upcoming talks. There'll be 2. Also, what we're going to have is on Twitch live at 4. We're going to show the Dev Booster final, which is 2 hours of pitches of video games that had made it into the top 4 of the Dev Booster competition for indie games, and they're going to be pitching in front of the audience as well as in front of our jury. And make sure to grab some popcorn, a coffee, an early beer. It's Friday, come on. And hope to see you soon, and bye-bye.
Thank you. Bye-bye.
Sorry, Carlos. I have a question about the Discord.
Yeah, sure.
Do we need a VR headset to participate in the study? I'm guessing yes.
No, you don't. No, it is preferred if you do, because right now, as in this very moment, we are thinking of targeting VR developers. We had a pilot study with VR developers, but maybe we are just going to open it up to everyone that wants to use movement in their games. But of course, join the Discord. The Discord is, you can just see everyone, talk with everyone, and you don't need to as well. If you join the Discord, you don't need to take part of the workshops and the studies if you don't want to. You can just read what's going on.
Thank you so very much for your talk and the information.
My pleasure.
Thank you.